The data seen below, it contains the desired operating conditions and current axis data. First, we select the ball screw from the Applications section. Now we check the desired speed and, accordingly, the distance to be taken. We will check this value again after entering the lead of the ball screw. For now, I enter the ball screw lead as 10 mm and the diameter as 20 mm. We also need to calculate the inertia of the ball screw for it to be included in the calculation. In the meantime, I decided that it would be more logical to start the calculation with 20 mm ball screw pitch and chain. Since our axis will run horizontally, we select horizontal and enter the length and outer diameter of the ball screw. Since it is a solid material, we do not write a value for the inside diameter. Theoretically, we can take the coefficients of friction as 0.001, but I usually take it as 0.01. Planetary gearbox efficiency values generally vary between 0.93 and 0.97. Finally, we enter the value of 200 kilograms, which is the total load of the system. Now we can move on to the servo motor selection. I choose the SGM-JB series with a low inertia ratio from the Yaskawa servo motor family and am trying to find a motor big enough to correct the inertia ratio with the Planetary reducer ratio rate. By looking at the inertia ratio of the servo motor, I am convinced that it can be used together with the Planetary gearbox, and now I am choosing a Planetary gearbox. The PLPE series is both economical and meets the desired maximum backlash of 6 arc per minute. However, the 50 size is not suitable for the connection of the motor I have chosen, so I switched to the 70 size. As can be seen, the 70 size Planetary gearbox with ratio 3 is suitable for my horizontal motion system.